Lab 1. So the purpose of the lab was to determine the percent of atoms with excess charge on the surface piece of a charged tape, and in general was to familiarize ourselves with fundamental laws of electricity. The models used, you'll see Coulomb's law, which is the equation to find the electric force, the electric field equation, which finds the electric field, and Newton's third law, which equal and opposite force, which we'll see later in the equations. So in this experiment, we had two charged tapes and tried to levitate or one tape using repulsion of the other tape. We did that by placing one tape on top of another tape and ripping it, using our hand to determine whether the tape is charged, whether a tape was attracted to our hand, and a negative pin to determine that the tape was also negative by repulsion from the pin. We used a rule to measure the distance, and we assumed that the only forces are in the vertical direction, that the only forces acting on the tape are from within the system, the two tapes, and not from the surrounding area. We treated the tapes like point charges because the charges are evenly distributed on the surface. So in order to find Q, we assumed because there's no momentum that the net force is equal to zero, and we put the electric force equal to the gravitational force using the length of the tape and a gram of tape for 1 meter. We found the mass of the tape, and we solved for Q. We assumed that Q was the same for both because each have even distribution and were created in the same way. So then we found the excess charge on the tape by taking the area of the tape and using the length dimension of an atom to find the area of atom, assuming that the atom takes up that whole space. Divide the area of the tape by the area of atom to find the total atoms on the tape, and using the charge found previously to find the total electrons, and dividing that by the total atoms to find the percentage of atoms with excess charge. Here are the results in more cleaner fashion. So for the code, here is the code and here is what it created. We found the charge was 1.225 e to the negative 6, which is different from the experimental, which is interesting. So since the experimental was 1.2 e to the negative 8th, we had a percent difference of 195%. Qualitatively, we also found the tape to be positive initially until we found out that it was supposed to be negative, and that could be due to doing it in my humid room. I was sick with COVID, so I couldn't go to lab, and using my hair instead for the pen. So, since we both assume that both tapes are the same charge, the tapes, whether it is positive or negative charge, will both repel each other, and you should not handle the tapes overly because it will use your hand as a ground source and neutralize the tape, no longer making it charged, no longer creating electric field and electric force. Conclusion: charged objects attract neutral objects as seen with the hand and the tape, like charges repel, as seen with the two tapes, and using Newton's third law, we can find unknown values.